So welcome everybody. For the people who just arrived, there's still some seats in front. If you want, don't hesitate. Like on the side, take a chair, turn it around, something. Or sit on the couch. All right, welcome to our 22nd Paris WiMLDS meetup. Wow, that's a lot. All right. So we're very happy to see you here tonight. The four of us are here tonight of the organizing team. So Caroline Xavier, co-founding member, Nathalie Czerneka, and Marina Vignes, and myself, Chloé Azencott. So we're very happy to welcome you and see many of you again, but also welcome to our new members. Okay. So what is WiMLDS, which is hard to pronounce? So WiMLDS stands for Women in Machine Learning and Data Science. We're part of a larger global organization. And our mission is to support and promote women and gender minorities who are practicing, studying, or interested in machine learning and data science. We have a code of conduct, which is fairly simple. We want to provide a harassment-free experience for everyone. So we do not tolerate harassment, and we're asking that communication is appropriate for a professional audience, including people of different backgrounds, and that you are kind to each other. So don't be aggressive when asking questions. Okay, so we thank you for making our community welcoming and friendly for all. With that said, so we're here together tonight, but we're on the internet all the time. We're everywhere on the internet. You can follow us on Twitter. You can join our Slack. The Medium is not here, but we also have a Medium webpage on which you'll find summaries of previous meetups. And if you want to get in touch, the easiest way is either Twitter or emailing us. And if you're tweeting tonight, don't hesitate to tag us or use the hashtag WiMLDS Paris. Okay. So for tonight, a few announcements. You got little numbers when arriving, and some of you were very curious about what that was about. We have a book raffle because so there's a TV show that's called Le Bureau des Légendes, who used a number of data science-related books in their shootings. And then they were like, okay, now we have all those books, and what are we going to do with them? And they decided to donate a number of those books to us so that we could distribute them to you for free. So that's why you have those little numbers. At the end of the meetup, after the talks, I'll use a random generator to distribute 1, 2, 3, 4, 5, 6, 7, 8, 9 books to the happy winners. All right. Oh, more news. This one is about myself. You may have heard about PRAIRIE, which is a Paris Research Institute in Artificial Intelligence. It's one of the 4 institutes that were funded by the AI for Humanity initiative. And I'm apparently to be highlighted for being one of the springboard chairs in PRAIRIE. And the interesting part about this is also that PRAIRIE is going to be partnering with us to increase diversity in the AI community. Okay, here's an announcement for Scikit-Learn workshop that's taking place on December 18, 2019. So keep the date in mind. We'll have more Scikit-Learn related announcements to come. Another event that's about to happen is API Days Paris in early December. We have a promo code to attend for free for WiMLDS members. And the idea is that we can't share it on Twitter or Facebook or social media, but if you're interested in the code, it's on our Slack channel. And is there any other way of, it's not on there, right? Okay. Okay, it will be on the Medium summary. Sorry, I'm not, I don't have all the info. It's my bad, actually. I was given the info and forgot it. All right. So you're here tonight at one of our meetups. It's one of the events we organize. We also organize lunch discussions about papers. So it's every third week of each month, and we discuss papers that are written or co-written with women, by women, sorry. And yeah, check it out. And if you're interested in that type of thing, you can also check every Friday. We have this Friday WiMLDS Paris hashtag, which is a bit long, but on which we share papers that have been written only or mostly by women, to highlight the research that is produced by women in machine learning and data science. All right. Our next meetup is coming up quite soon. It's on December 11 at VP Tech. It's going to be a joint meetup with DDDFR. So now I have to remember what DDD stands for. Design-driven development, thank you. And we're going to have Audrey Neveu coming to give a keynote at this meetup, and a bunch of presumably also interesting people that I don't know about, but I'm sure they're great. Sorry, it's actually not even true. It's just that we're very excited about Audrey Neveu. We're happy about the other speakers as well. All right. So tonight's agenda, let's get started soon. We have, as usual, 3 talks. The first one by Alice OTHMANI, who's an associate professor at UPEC on artificial emotional intelligence. Then we have Imen El Karoui, who's a data science lead at Caring, talking about building and managing a data science team. And finally, Sonia Bahri, who is right here, who's advisor to the president, the French National Commission for UNESCO, will talk about women in technology. And afterwards, we'll have the raffle, and then we'll have some time for networking around pizzas. All right, let's get started.
Hello everyone, so I'm Alice OTHMANI, Associate Professor at the University of Paris-Est Créteil, and I will be discussing today some of my recent research work which concern artificial emotional intelligence. So the idea how to understand human emotion from several modalities. Today I will be discussing only 2. I will be discussing speech and audio for 2 main applications, human-computer interaction and for the diagnosis of mental state. So artificial emotional intelligence, we call it also affective computing, is the science of recognizing, interpreting, processing and or simulating human affects. So the idea is to start by recognizing emotion from different modality and then simulating this human affect by computer. What's affect? We describe recently affect as a 2-dimensional space by calling Valence and Arousal. It describes the experience of a human emotion resulting from an interaction with a stimulus. So we have for the first dimension, we call it valence. Valence is the degree of pleasantness, and arousal is the degree of activation or disactivation of an affect. Okay. Previously, we are working in more discrete function where we have several type of classes like joy, sadness, the other type of emotion. Recently we have a new definition of emotion and we try to work in more continuous space in 2 dimensions, which we call it valence and arousal, which can define our state of happiness, of angry, sadness or relax. Okay. Recently, we are focusing even in n-dimensional space with we are trying to give a new definition with a more high-dimensional space. But today I will be only focusing in 2-dimensional space in valence and arousal. So human, they can express affect using through several modality. We have face, we have our speech, audio, or gestural behavior. Why it's interesting to work or to understand human emotion? There is 2 main applications. First, by giving machine skills of emotional intelligence, which could be an important key to improve human-computer interaction and to understand interaction with other humans. The second application is to understand human emotion, and then to give the human a socio-affective intelligence. Okay, so the idea first to understand a machine will be able to understand the human emotion, or a machine could be to understand the reaction between two humans and then help the human with a socio-affective intelligence. Artificial emotional intelligence is inherently challenging problem with a broad range of application. It can start from human-computer interaction, we call it HSE. We have also health informatics. Today I will be discussing one application in health informatics. We have all assistive technology and also media retrieval. Okay, during this talk I will be presenting two recent work we have developed to analyze the speech, and the second one is to analyze faces images. So I will be discussing some new deep neural based approaches to understand the human emotion and mental states from both modalities. Okay, so the first paper was published recently. It's a deep multifacial patches aggregation network for expression classification from face images. So you can find it in archive. So from human faces, our pipeline start by extracting facial landmarks. From those facial landmarks, we will be extracting some patches. These patches will feed to a multifacial patches-based CNN to give by the end the facial expression corresponding to the face we have processing. Okay, for many reasons, the existing data set of human emotion is very small, and to solve such problem, we are doing many data augmentation techniques to generate more images with face expression, or to generate patches in our case. So from the face images, we will be extract some key points. We call it patches, which will represent the main key parts of a human face, like nose, eyes, jaws, or other ones. Those face parts will be given to a subnetworks. Each the aggregation of these subnetworks will be concatenated in one layer to give by the end the facial expression. Okay, so this is the main architecture. We call it MFP-CNN. Our images, they are not high resoluted for many reasons, and for that, to avoid overfitting, we have not very deep architecture. After trying several configuration, the setup was to only choose 3 convolutional layers, and it gives a very good result. Okay, the second part is data augmentation. Unfortunately, all the existing data set for emotion expression, they are very small. There is only one given by Google, which contains 3,100 images, but all the rest, we are around some 10,000 images. Okay, so to generate more facial images, because we need a lot of images to train such a deep neural networks, we need a lot of data, and for that the first technique was to use conditional generative adversarial neural network to generate more images. Okay, so CGAN, for those who didn't know such a model, it's contained by 2 adversarial model. The first one, we call it a generator. It captures the data distribution, and the second one, we call it discriminator, that estimate the probability that a sample comes from the training data rather than the generator. Okay, so it's a min-max optimization problem, and where the generator will try to maximize the log probability of labeling real and fake images correctly, while the generator will try to minimize it. Okay. Here in our case, we give it a new definition for the loss function of the generator, where we consider the adversarial loss, the piecewise MSE loss, and the perceptual loss. It's a combination of the three, of those three, and we will try to normalize it to all the training images. Okay. For the loss function, we keep it the same definition as in all GAN definition. We doesn't change it. And I think next slide, I will be showing some results of that. Okay, now later I will be showing some results of these CGAN. Okay, also for the same reason, we doesn't have a very high big resolution image, and for that the generator and discriminator doesn't contain a big or a deep architecture. It's only with the 3 convolution, and it gives also a good result. Okay. For our study, we have concentrated in the Ekman emotion classes, which represent 7 emotions, which we consider as universal and doesn't depend in culture. It exists, or it's a cross-cultural emotion, and we are talking about happiness, anger, disgust, surprise, concept, sad, fear, and neutral. Okay, so here we can see that our generated images, they are fairly still realistic and close to the human face. We need a lot of training, many days to get a better results. For many compromises, we doesn't go for many days, but still after several hours and several iterations, we got a very realistic one. As I said, we generate also some patches, and for that we use some T function, some transformation function, as simple as the whiting, shifting, translation, and so on, to get more data. Okay, here I present some of the experience we have realized in our work. And in the paper you will find much more detailed experience. Here I didn't explain all of them for time reasons. So for example, here we can realize that the last experience where we consider all the data set plus the generated images and the generated patches, it gives the best accuracy. When we do only the original images, or we add one of the generated one, it's still less performance. So we have 98.07% for the accuracy for recognizing emotion in the CK+ dataset, which is one of the biggest dataset and the used one in the state of the art. You can find in the paper a comparison with existing method. Here I didn't present it, but you can see that we are quite championed. Okay, here I will not present all the confusion matrix for the realized experience. I will present only one, just to say that the conclusion that we have when we doesn't have enough intense experience, like for the case of neutral, disgust, or sad, we have a more misclassified images. So the one that represent more misclassified classes is the contempt, sad, and neutral. Okay, when we doesn't have a very intense emotion, the computer hardly discriminated, and maybe also it depends. There is a lot of information between identity, ethnicity, and so on, which makes these emotions more confused than others. Okay, now I will present a second research work published recently also. You can find it in archive. It's about clinical depression and affect recognition with an architecture we developed. We call it Emo Audio Net. Okay, so we have two objectives behind this work. The first is to analyze automatically the emotion and affects from speech. Okay, we want to develop a deep neural network that can be able to recognize emotions from any speech signal. The second one, we want that our deep neural network is able to recognize depression, which is a mental state. Why we are interested in that? Because according to because according to the World Health Organization, we have the new report which said that the second cause of death among a child between 15 and 29 years old is suicide. Suicide which came from depression. Here we have the statistics said that there is 300 million people affected by depression in 2017, and we have, according also to this report, 38.7 European population which are affected by depression around 2020. Okay, so it's a big mental state problem that we should take it seriously into consideration. Okay, so our goal is to diagnose in time depression for a better diagnosis and a treatment for patients. Okay, so we want to develop more diagnosis tool for depression. Okay, unfortunately in the clinical case we have only third of depressed people which are correctly identified. It's still even hard for a psychiatric person, for a doctor to recognize even depression. For the depression diagnosis, it's usually the doctor will use a self-assessment test. We have two main ways to do it. We have the patient health questionnaire, we call it the PHQ-8, and we have the big depression inventory. Okay, for our case, we have been focusing only in the patient health questionnaire, which is a multiple choice self-report questionnaire. We give a score from 0 to 23 to describe major depressive disorder, which we call it MDD severity level. So the person who are strongly depressed, who have a severe depression, will have a score which is close to 23. Person who is normal, not depressed person, who will have a score close to 0. Okay. So our intuition that from the audio we will do some short time spectral analysis and then visual representation of the spectrum of frequency for a better and a good parametric representation of the audio signal. So our short time spectral analysis is based in the MFCC. We call it the ML frequency spectral coefficient. And for previously realized research work, they have said that even the spectrogram of the audio signal contains some texture which represent, which is unique for each audio speech. Okay, so the idea is to combine those two information in a deep neural network for clinical depression recognition. So we have proposed a new architecture. We call it ImmoAudioNet. It's an aggregation of two networks. The first one is a spectrogram-based CNN, and the second one is an MFCC-based CNN. So in the first one, of course, after doing some data augmentation, because we doesn't have enough data set, it's medical data set, and even it's more smaller than the rest, and there is a lot of confidentiality reason behind, and it's very complicated to get such data set, and so on. So we need some data augmentation. We extract the spectrogram. We will do several layer of convolution, max pooling, and so on. So this is the spectrogram-based CNN. And the second one, from the audio signal, we will extract the MFCC, and we will make a 1D convolution. It's only the vector. It's not 2D in this case. And the aggregation of both of them will give us the final response of the two neural network. Okay, we realized our experiment in one academic data set, I will say. It's used in several challenges. We call it the DICOS corpus. It contains speech, some landmarks. It contains also some physiological data like EEG and so on. In our work, we have been using only speech data from this data set. So it's based in the PHQ scores. And for us, we have been concentrated into tasks. First, recognizing depression. So we call it this PHQ binary to recognize non-depression or depression. And the other one, we have the PHQ 8 scores to recognize and assess the depression, so from 0 to 23. Okay, it's not balanced data set, so we have been solving all this problem during the processing. So for more detail, you can check our paper. Okay, the second data set for affect, we used also a data set, we call it Ricola. It's used in many challenge, and you can get more detailed about it. So it corresponds to a 23 audio recording of 5 minutes. It's also same a multimodal corpus of affective interaction in French. For us, we consider only speech. So we have a 6 annotator which have been measured emotion continuously in the 2 dimension. As I explained previously, valence and arousal. So here in this case, there is no the discrete number of classes which are sad, happy, or so on. So it's much more in the 2 dimension. The valence, it represents the level of pleasantness. So it's a continuum from negative to positive, and the arousal is the intensity and the level of automatic activation created by an event. It varies from low when you are calm to high when you are excited. Okay, so the result of our data set, we start by comparing the result of IMO-AudioNet in the affective recognition only by using the MFCC-based CNN, after by using the spectrogram-based CNN, and then the aggregation of both of them, which we call it the IMO-AudioNet. So we have realized, of course, that the aggregation of both of them gives the best result with an accuracy of 89.30%. Okay, we have also we try also to push this expanding of the labeled or training data set by doing a fine tuning. So we pre-trained in more bigger data sets. In our case, it was the Libri speech data set, and then we fine tune in Ricola data set. So we got even a better result for the case of prediction of arousal with a 90.37%. Okay, which is the best accuracy getted in the state of the art you can find in our paper in comparison with the existing work. In the second part, which is the prediction of valence, we found that the IMO-AudioNet without any fine tuning give the best result with 91.44%. Okay, here unfortunately some of you can be surprised, but we interpret this by the fact that the feature extracted using the Libri speech dataset are very abstract and they are not related to the context. Is why when we train in this dataset and fine tune in our Ricola dataset doesn't work. So even the approach of fine tuning, to conclude, is not always a better approach. Okay, so for depression assessment tasks, we found that our IMO-AudioNet with the fine tuning give the best accuracy with the 74.13%. Okay, to conclude, we confirm the ability of automate the analysis of emotion and affect recognition from face and speech is totally possible. In fact, what we are doing majority in the academic, we are working in a lab-controlled data set, so it doesn't really represent the real world. There is no the problem of occlusion, elimination, for example, for the face, we have a very good condition of acquisition, and it's not really the real world. So the idea is to go to the in-world environmental condition and test such networks in more real data set. So there is a big problem in the small size of the existing data set and the high number of parameters to learn. So it's one of the point we should be working on in the next years. There is also the lack of generalizability because we have different data sets acquired in different conditions and real world scenario, and the idea is when we train a network, it will be able to have the same behavior in other data sets. Okay, thank you.
Okay, we have time for 1 or 2 questions.
Hello, thank you for your talk. You mentioned in your first part of your presentation that there was little data available. So where does it come from? Is the data set open, or you have to do?
You should sign a lot of paper, and it should be signed by the head of the lab, the head of the university, and it will take many weeks and days, and it's so complicated. And sometimes you should, even when you have a member that it will start working, especially with this medical data set, each time you will add. First, for example, for the visual data set, we doesn't have the real images because for the privacy of a person, and so on, we cannot get such data set. It's so sensitive. And you should go to the CNIL, ask for recommendation. It's so complicated, especially here in France, and it's one of the big problem for us here. It's I know that some people will not agree with me. Okay, confidentiality, I agree. Privacy, I agree. But also, if we compare, for example, with China, which doesn't make any restriction, yes, they progress very fast because they have data.
And couldn't you use data from movies to try to spot the emotion?
This CK Plus dataset, actually, it's a continuous image. It's like a video. They take it from a low intensity image until the high. For example, it starts from neutral force, being very happy, smiling, the extreme smile, and they take it in real time. So it's very close to video, but it's not video. We have tried, but we doesn't demonstrate it in the paper. We have tried even with webcam, with some images, extra images, and it still works well.
Hi, thank you for the presentation. I had a question on the second part for the speech analysis. So you mentioned the 2D space of the emotional representation. My question would be, because this 2D space is cross-cultural, is the speech analysis independent of the language, or is it biased by a language?
Actually, we have a new data set. It's very recent, where we have many ethnicity, so many languages. We doesn't yet experiment this. It's a new challenging topic, and the idea actually to see if from one ethnicity to another we have the same accuracy. We have studied in other data set age estimation across ethnicity. I didn't present. We have a comparative analysis paper in that, and actually for some more close ethnicity we have the same accuracy. For a more for example, from if we train in white people and we test in black, it's more harder. We doesn't have the same accuracy.
Even for the same language?
I'm talking about face. For language, we doesn't try yet.
Okay.
It's just a new data set, but it should be the same.
Okay, thank you.
You're welcome.
Okay, a very short question. Thank you very much for the presentation. And actually, it's also a question about the data. So for the first presentation, did you separate the persons in the training and testing data? I mean, is there like...
It's person independent. It's person independent, our approach.
Yeah, so they were separated in the very beginning, and you...
Those person who are in the test, they are not in the training, they are not in the test.
Okay, thank you.
Imen, welcome. I wanted to correct. Imen is the head of the AI factory at Kering. Boom.
It's a super fancy name, but I actually hate the AI part. So I prefer talking about machine learning and data science, but it's less commercial. So anyway, so it's not going to be super technical today. The idea is to actually give some tips and tricks on basically building a data science team. And actually, you've probably heard that data scientist is potentially the sexiest job of the 21st century, but we never mention the managers of the data scientist. And so today I want to talk a bit about my experience as manager of data science teams. And so obviously it's just a quick intro on what I've been doing in the last years. So I've actually studied biology initially, so it's not super usual in the field. And it's actually super nice. And I also realized quite quickly that in biology, you actually need stats. And lots of people don't know any stats in biology. So I did some classes of statistics at some point over there. And then I did a PhD in cognitive neuroscience. So I've basically been learning stuff about data on brains. And then at the end of my PhD, I realized that I didn't want to stay in academic, but I loved analyzing data. So I ended up at Kernix, that is a small company of about 50 people that are developing a website initially, and they were launching the data science activity. So I basically was involved in building this thing. And then I arrived at Kering. So Kering is the group of Gucci, Saint Laurent, Balenciaga. So you probably don't know Kering, but you probably know the brands. And we are building up lots of initiatives around data and the AI factory. So that is basically the team for data science in the group. So basically, the first tips that I want to share is that it's super important to actually know what you want to do, which is not so easy when you're building an activity because it's kind of unclear initially. So the first question that I think is important to realize is what is the level of maturity of the organization in which you're involved in machine learning and data science. So typically in my two experience, so in Kernix, we were a consulting firm. So basically we were really asked to understand super quickly the business of our clients and to build machine learning algorithm for this business problem. But then we were not really involved in the maintenance of the algorithm and all the things that comes after just the first step. Actually at Kering, it's kind of a different approach. So we're here on the long run, obviously. So we're also in a very early stage because basically Kering is not using data for a long time. So it's something it's a company that is really not digital 2 years ago and that is building capabilities on this. But the idea is that we need to understand the business quite intensively, but also to focus on the industrialization and the change management because we're working with teams who are not used to using this type of models. So it's quite important to focus on this. And obviously it's quite different from Google. So I wasn't there, but machine learning is obviously at the heart of their business. So they're way further in terms of maturity. And so basically what they are doing is basically maintaining models and optimizing models that are already there for a long time. So obviously, depending on what you want to build, you're going to be somewhere inside this curve of maturity, and it's quite important to realize where you are, but it's not always that easy. The second thing is, so depending on where you are, you basically need different skills. So this is my view that can obviously change and is open to discussion. But basically, I think that in a data science team, you have sort of 5 skills that you need in more or less important ways. So the first thing is you need to understand the business problem that you're actually trying to solve. Otherwise, you can do anything with data, but it's not always relevant. The second thing is you need to be able to get insight from data and understand the project, like the data you're actually dealing with. Obviously, the only thing that we talk about is machine learning and stats and math, but it's just one part. You also need to be quite good in terms of software development, and it can be, like, especially when you're more in the maintenance phase, it can be a super big part of the work. And it's also important to have an infrastructure to actually do all the computing. So in your team, you need, in some ways, to have all this. And you need to weight all these capabilities accordingly to the first question that you ask. And the last thing that you also need to think of when you're building your team is actually what is going to be your role in terms of like team managers. And it can actually be quite diverse, and we tend to try to do everything, and it's quite hard, so it's probably not the best idea. You can obviously be like a mentor and a manager. You can also be a tech lead and be more on the like technical aspect of stuff. You can also handle project management. You can be involved in communication, obviously, in your team, but also outside for the rest of the organization or in meetups. And you can be also involved in more commercial activities. You sort of need to figure out what is expected from you, what you actually like and what you dislike to actually build up the right role for you in the team. So that's a lot of questions already. And so then my second advice is that probably it's not a good idea to find someone who is going to do all this, because like I've been trying, it's not working. So actually I think it's a better idea to actually have a team to build everything on this different stream. And it's actually nice to value diversity. So I guess I'm in the right place to say this, but I actually believe in it. So typically you're going to need people on these 5 different streams. But for example, in my teams, I have data scientists who are more on the business, data, and ML side, some that are more on the ML software development. I have data engineer who are more in ML software infrastructure. Anyway, you have people who, and like the job title doesn't mean much. So it really depends on people, like what they're interested in. And so it's important for you to analyze basically what are your strengths and weaknesses and recruit accordingly. So typically in my case, I know that, and also in terms of experience, not just in terms of skills. So I know that in my team, people tend to be a bit too junior. So I'm actually looking for more senior people to actually build up, especially on the ML and software development side, to actually balance everything. And the second thing is that, so I do value diversity, but it's clearly outside of your comfort zone, meaning that it's way easier to work with people who are just like you, and this is why like teams tend to be not diverse at all, because the manager tends to recruit people who are just like them, which is easy to manage, for sure, but you're actually missing a lot of the value. So typically in my team, I have people who are more from the infrastructure side, and so typically when I arrive, I was a bit scared about it because it's just not a field that I know. And actually, it's kind of nice, like several months from the beginning, to see that they actually learn a lot about machine learning, and now we're like talking together, and we like just seeing everyone learning stuff. It's very nice as a manager. So in the end, I'm super happy that it's diverse like this, but it's not an easy path. And so obviously, the first diversity that matters here is gender diversity. This is my team, so I'm pretty bad at this, but I've been trying. Actually, I used to be the only one because I'm here, so it was pretty bad. And also, like, the team next to me, there's 16 people, and it's only men. And I was, like, really the only one among 30 people, and that was feeling lonely. And it's actually especially important because at Caring we are selling like handbags, and actually knowing what you're actually looking at when you are buying handbags is something that is key to actually get right features. So having women in my team is actually something that I'm really looking for, but it's not that easy because I just there's not so many in the market. So if there are some here, you know what I mean. Actually, the other stuff, so this is just a joke, this is why there is no source about the data, but it's actually the difference between biology and physics. So this was my word in PhD, so basically a notion of noise and a bit of signal, but not much. So basically I've been trained to look at noise and to actually analyze data in this way and trying to find like the right information. While I was discussing with the person I was working very closely with at Carnix, who did a PhD in quantum optics, and basically his data was so clean that I was super jealous. And basically, like, he didn't know anything about hypothesis testing because just like he didn't need it. Like, it was beautiful Gaussian data, and like just getting the standard deviation was enough. And I was like, okay, well, we're not coming from the same world. And it's actually something that is important because, like, for example, even at Caring now, like the sales that we are analyzing are kind of erratic because in luxury you don't have like many sales for one customer, except for a few, but basically not so many. And so actually analyzing the trend is something that is quite tricky. And so like being used to having ocean of noise is actually something that is quite useful. So I think it's also important to have people who are not all coming from the same background. And the last thing about diversity is also culture. So about 30% of our customers are Chinese. So it's quite a lot. But we are super Western-centric. Like everything is based in Paris, so like even in the company in general, it's kind of a problem. And basically, one team that we're working with is working on the duplication of customer profile. And so the rules based on Western way of thinking are based on your first name, last name, and address, and that kind of thing. In China, like lots of people have the same last name, but like the phone number is key because lots of them are using WeChat, and I didn't even know WeChat before arriving here. And so basically having some knowledge about other people when you're working in a company that is implemented worldwide is really very key. And so basically, once you have identified all this, you have to go for interviews. I'm not going to go into interviews because it's a whole topic in a way. But the only thing that I want to say is that it's very important to actually define, obviously, the technical skills that you're looking, but this is the easy part, but also the soft skills, and to be quite precise in what you are looking for. Like if you want people who are curious, if you want people who are rigorous, and think about this, and then think about the question that you want to ask to actually evaluate this, is something that is very useful. And it's important to keep your question very open and concrete. Like this is one that I like to ask, that is, what is the last thing that you learned and how did you proceed? It's actually super useful to know like on which topics people are interested in, how deep they are going when they are learning something, like if they are interested in something else than machine learning. So it's actually quite useful. And the last thing, but not least, sorry, is actually, do you see something weird on this picture? So it's a Colgate advertisement. You say anything? Yeah, so okay, so he has something in his tooth, but he actually has a sixth finger that you probably haven't noticed. And this is actually because you just want to see, like you know what you want to see and you don't look at stuff that you're not looking for. And so it's actually quite key in interviews because you will tend to look at people with your own bias and tend to think that they are like you want them to be, and it's probably not the case, so be careful when you are actually asking questions. And the last thing is that actually once you have done all this and you have a diverse team and you're happy, actually keeping your team is the hardest part, because we're in a field where people are contacted on LinkedIn like tons of times a week, and also they are kind of, so they always see the green, the field greener on the next slide. So it's actually super like hard. And I think one of the reasons for this is that many data scientists, including myself, are basically motivated by challenging work and learning opportunities. And this is hard to keep in the long run. So I think it's very important to try to create, that's not perfect, but try to create a learning environment so you can actually have some opportunity to grow even if you're in the same team. So one thing that I've been organizing is a journal club. So I come from like a PhD, so we're used to this. So the thing that I like about it is that it opens up like people, just because we're not covering like project-related papers, but everything from ethical fairness to like anything, to deep learning in production, whatever. Even though we're not necessarily doing deep learning. So this is something that is quite nice. The other thing is to organize code review and pair programming. So this is more on the like software development thing, but it's actually a very nice way to learn and also to bind with people in the team, which is also something that is a nice way to keep people. And the last thing that I've been trying, not yet so successful, but I think it's really a nice way, is to give some freedom to test new tools and methods, but in dedicated time. Because so obviously this is what we do every day in the project, but you usually don't have the opportunity to test all the stuff that you see on papers and that looks nice. We're clearly not here for doing the shiniest methods just because it's shiny, but it's nice to have some time to test some stuff. So I think this is quite important. One other thing that is important for me is that we organize regular one-on-one to give feedback, but also to get some, because it's a nice way to like have feeling on what is going on, and also to detect quickly stuff that are not going so well, to keep up on this. I think also it's good to have some more structured one-on-one, like several times a year, but not every week. Just because, and have them structured so people can think about what they've been learning, and it's a nice way to actually have critical thinking on yourself. And you learn a lot in this kind of thing. And also it's nice when you have workshop with the entire team to take the opportunity to get a lot of feedback from everyone. Doing this, I've realized that the group was not really a group like a few months after I arrived, which was not completely clear for me at the time. So it was a nice way of detecting something that everyone shared, but was not clear for me. And the last thing that I'm not doing, but I want to do it, it's basically that I come from academia, so I'm not used to this. But having a clear visibility on how you can evolve on a technical track, but also management track, is something that I think is super important. Although it's super tricky for me because typically I don't know what we're going to be doing in 5 years. So like in terms of how the team is going to be evolving, it's super hard because we've been like existing for less than a year. But I think it's super useful to give some visibility to the people in my team. So if you're interested in this topic, this paper is actually quite nice. I've discovered it on like a newsletter, and it was nice for me because I realized I was not the only one struggling on this, but they came up with ideas that were sort of similar to mine, so that was happy. And the last thing is we're actually hiring, so if anyone is interested, that's the opportunity. And thank you very much.
questions?
How did you hire your team?
How did I hire my team? So this one.
Yes.
This one is actually partially external consultant and internal. So we're 13 people already, but I hired only 2. And so it's actually easier to work with external people because it takes less time. And what I did is actually I'm not doing technical interviews anymore, really, because it was working very well for junior when they came up at school, and so you actually need to test them. In the end, like when people have just even a year of experience, just going deeper into one of the projects is actually as useful as the technical thing.
Thank you for the presentation. As a young data scientist, don't you think there is a fantasy about data science and machine learning, deep learning, and I would say a fantasy between what we see in the papers, all the meetups that you can go to, and the reality that's really happening in the companies, and what you actually really do when you work in this field. And because of this, a disappointment that when you're working in this field, you can have, and that managers can feel, and maybe it can explain why it's so hard to retain people.
So it's very true for some people who are very interested just in the algorithm, and I tend not to recruit these people because we're not a research team, for sure. We're super operational. Although I have to say in Caring, we are quite lucky because we're actually doing machine learning, and we're not just doing data prep. That is like what I saw in the consulting firm, like, and this is one of the reasons why I left at some point, was that it was not really data science, but more just ingesting data, which was not really my thing. So at Caring, we're really doing machine learning, so I don't really have this issue in this team, but I fully agree that in general, just also because of the maturity of the different like companies, it's quite often the case that you don't really have access to data. So how do you do data science without data? It's actually a tricky thing. So I fully agree that like it's there is some hype for sure, and that like if you just look at research paper and you're not going in a research like company or lab, you're going to be disappointed. But so this is definitely something that I try to be careful about when I recruit. But I think you can find some teams in which you're actually doing machine learning.
Thank you. Hi, thanks for sharing. I have a question. It's about what kind of problems are you solving with machine learning, and what kind of projects are you working on?
So basically, we're working on 2 types of projects. The first one are like on clients. So basically, the idea is to score clients on their potential. So basically, identify the ones who are at high potential. Because basically, so in luxury, it's a bit specific as an industry. Because basically, when you're going to a store, you're going to be facing a sales associate, and you're going to have a real discussion with this person, and they can like come back to you by phone. So obviously, you're not going to do this with 40 million of clients, but you want to identify the ones who are a high potential to come back to actually activate this in this way. And we're also doing product recommendation, which is quite of a challenge in luxury again, because basically our challenge is that we don't have that many interaction between customer and product, because they're not buying like product over and over again, because it's quite expensive. So it's a challenge to actually understand how you want to do this in the right way to not have too sparse data. So this is one of the stream, and the second stream is on supply chain. So the idea is to forecast sales on short term to actually allocate product to the right store at the right moment, or on long term, because basically we do have a pretty long lead time because it's still quite craftsmanship things. So it takes about 4 months to like produce handbags. And so you have to decide pretty much in advance like the quantity that you're going to be producing. And this is quite of a challenge because like you don't have a limited space in the warehouse, so you have to address this correctly. So it's actually machine learning in all these cases.
Thank you.
So before I'm calling Sonia Bahri on stage, I'm just going to tell you a little secret. The whole team almost met her in May at a conference celebrating Imen El Karoui, a famous mathematician. No correlation with Imen. And we were astonished because, you know, there were discussions about women in STEM, women in tech, and Sonia was saying arguments with data, with perspective, and we were like, at last. So tonight she's going to give a presentation about, we're going to step back and look at the situation and solutions as well, because naming it is okay, but what's better is to act upon things. And so Sonia, the floor is yours.
Thank you so much. Thank you. Thank you very much. I'm really pleased to be here today with you. And I would like to congratulate the team, all the team of WiMLDS. That's the way we pronounce it. And for this initiative and all other initiatives, it's really a great job you are doing. So I am really happy to be here with you today to speak about women and technology. So it's less and less technical, I would say. So technology is, as you all know, very much related to science, mathematics. You know, we rely on science for technology, we rely on technology for science. They are very much interrelated. And when we look at the figures, when we look at statistics worldwide, they are quite worrying. Only 28.8% of researchers in the world are women. And with this, we have a very little recognition, of course, of women doing science. And we have only 3% from the very beginning of the Nobel Prize the recipients who are women, including Marie Curie, who got 2 Nobel Prizes. So just to give you an idea. And this map shows the gender gap in science. And maybe those who do not have ideas about how it is, it's interesting to see that countries like Western Europe, North America is not here, but because it's a question of statistics from the UAS, the UNESCO Institute of Statistics. But I can tell you the color is really light purple, just like France, like other countries. So you see that women scientists are actually, we have more researchers in Latin America, especially in Central Asia, also in other countries. Well, I am both French and Tunisian. I'm very proud of it. And you can see that Tunisia there, this little country where we have some representatives here from Tunisia. And you three, good. So, you know, we have made 100% tonight. Thank you, WiMLDS. It shows that, you know, there is a kind of correlation, actually. But you didn't know it. It was not conscious, you know. So I'm proud of it. I'm happy of it. So this is sometimes against our own stereotypes and prejudice about where the share of women scientists, you know, we would have think that maybe in France and Europe it would have been better, and we hope it will be better. Because when you look at the pictures and the statistics, you can see that what we have seen in the map, and you see that Europe is near, we have more or less the same share than Sub-Saharan Africa, and then we go to East Asia and the Pacific, very low, and the lowest is South and West Asia. Well, I won't go too much about this, but you know, this is in our science report. It's interesting because it shows that in the very beginning, till the PhD level, women that are there. They are in science there, but after it goes down after PhD level and even lower for research careers. And when women go to science, they will rather choose, like Imen in the beginning, life sciences, biology, you know, and less physical science, engineering, what we call hard sciences, and especially computer science. And only 12% of researchers in artificial intelligence in the world are women. 12% only. When you look at this, you see that you have men in black, men in black, and you see, you have here the share by countries. Not all countries are represented here, but you have a good idea of what we have in the different countries. So very, very small proportion of women. And this is like an ecosystem, actually, because you find only 11% of computer science students at high school. Then you have, you know, at university level, something like 10% of students in computer-related specialties. And for engineering schools, which is wider because you have several fields in engineering, 27%. So this is for France. I am going to give you the figures only for two countries, France and the United States. If you want more details, you can have some information. I have some more information, but you see that this after has an impact in for the world of work, because you have 33% of women in the digital sector in France, but only 12% for the technical part, not the business, not other parts, not communication. And for the startups, 10% only are created by women. For the United States, you have more or less the same figures. And for example, in Google, they have a lot of employees. They have 31% of female employees, which is not that bad because it's more or less 1/3, but you have only 20% for programming jobs. Same thing for Facebook, more or less, with 19% in programming jobs. And we can say that when we look at the trend for the jobs in computer science and the computer science degrees, instead of a progression, we have trends that show us that the situation is getting worse. This is why I was saying that it's worrying. The situation is really getting worse. You can see here in 2017, what was the situation in the United States, 22%, and then of computer science degrees, and then and before it was in 1984, so in the 80s, 40%. Same thing for IT jobs, you see, 25% and 36% in early 90s. And we can predict that it will be even worse, of course, in 2027. This is something that has been produced by Girls Who Code. Well, why this situation is not acceptable? Well, because some people say, and I have some serious discussions sometimes with people, ministers. We just had our general conference at UNESCO, and people say, well, you know, maybe why do you want to have equality in science? Why? I mean, you have people going in the army, men prefer army, and women ballet. So why do you want to have this equality? I think it's important because we have really to advocate, to be good in advocacy, because we have to look at what is at stake, actually. What is at stake? And when we look at these pictures where you see women in computers, working in computing, at the time, in the 50s, 60s, and you will see that even before, at the time where this was not highly valued. At that time, we had a lot of women doing computer science, but now that it's getting very important by the combination of artificial intelligence, because this existed in the 50s, but combined with big data, it's now becoming very important. This is really the digital revolution. The sector is expanding, and women are kept out of it from this high value added sector. Very well paid jobs, as you know. So this is bad for women, of course, not being in the picture. And also, as artificial intelligence is transforming our societies, the way we move in the city, the way we travel, the way we are on the roads, the way we choose our studies, everything in our lives, and is going to shape probably the future, women are out of it. So this is a question also of a human right issue, because from the jobs side, every constitution, more or less in the world, says that there is an equality for access to jobs. And we have, I mean, in the practice, it is not there, because the figures show us that it's not there. And in terms of numbers now we have such a demand, and Imen was talking about it. We have the kind of demand for computer scientists, and we don't have, I mean, to meet the needs, and this is clearly mentioned in Cédric Villani report. I'm sure that many of you have looked at it. The men scientists, the engineers that are working, the researchers now on AI, are not enough. We need to double or even multiply by 3 the number of researchers and engineer males to working in the sector to meet the needs. So without the women, it will be necessary to increase immigration. And this may create sometimes, not at individual scale, of course, it can be very successful, but when you look at the macro aspects, it can create problems for the countries of departure, the countries who trained. I'm taking the case of Tunisia, for example. Every year you have 12,000 Tunisian engineers leaving the country. And I know that for Egypt, it's also something similar. So the government has spent money on it, has invested, and wants to have the results, the outcome of this investment. So it is a problem. Then after, it could have also some social problems for the countries of arrival, but especially for the countries of departure, it creates a problem. There is a miss to win for economic growth without women, not having women being part of this industrial revolution. McKinsey, in a study, they evaluated it to $200 billion of euros. So this is of additional GDP. So it's really something that can be measured, and we cannot afford to deprive ourselves of half of the talents of humanity. So now on the qualitative side, you mentioned it before, even in your presentation, that there is evidence that diversity is beneficial to organizations, all companies. For it is very important to have men, women, and diversity, ethnic diversity. It's important, of course, when we think of artificial intelligence, data science, and you mentioned it also, the importance of having enough women involved because of the problem of quality, relevance, reliability. So we didn't mention it, but algorithmic biases is really an issue. And of course, we cannot give examples, but we have to keep in mind that these gender biases in algorithm are going to amplify the phenomenon of discrimination. Why? Because if you don't have women, because we know that behind the codes there are people, human people. And if, for example, for job opportunities in the field of technology, women are not targeted because of the programs that are offered online, then we amplify the risk. So this is a kind of vicious circle. So it is this is another argument which shows how much it's important to have more women in the field. So how to change the game and create opportunities? This is why it's important also to look at these aspects. And I think the very first thing we have to do is really to tackle the root causes of inequality. Because the better we understand it, the better we can manage it, and the better we can change things. Stereotypes, social norms, all this, I mean, it can be conscious or not conscious, but we all have them. Sometimes we don't know it, but we all have them. They are conveyed by everyone in society. Parents, teachers, even female teachers. This is a reality. And you probably have heard people say, oh yes, women are not so good in science, not as good in mathematics. And these are things that are coming all the time. In textbooks, these stereotypes are conveyed in textbooks. How many of you have heard of Ada Lovelace? Good. I see. I know that I have the public is great. But how many of you had heard in the past, in their textbooks, of Ada Lovelace? None. One in a textbook. In which country? In Ukraine. Great. But have you seen that Ukraine was part of these countries, not in light purple, but in dark purple? Well, this is why I asked the country. Because studies were made, no mention of Ada Lovelace, no mention of other scientists of the past, 18th century, Hortense Laporte and others, you know, who did in 19th century. Women who really, I mean, Ada Lovelace, as you know, was the first computer programmer, but not mentioned in school books. And in school books, we mention Marie Curie, and when we mention her, it's with Pierre and Marie Curie. Discrimination, I mean, is also in toys. The first computers that were offered to adolescents were for boys. There is the myth of the geek, the nerd. I mean, it's rather this picture than this picture that people have in mind. And, well, we have to really fight this, but Albert Einstein said it was harder to crack a prejudice than an atom. So we have really to show that it's not true. What you are doing here, guys, is really to try to contradict him. Easier than the general theory of relativity. There is also in the root causes of inequality the orientation of girls towards discipline, other disciplines than STEM, from school to they are oriented. So it means that teachers, that counselors are pushing that direction. Parents, there's also the issue of sexual harassment, which is sometimes assimilated to, you know, Silicon Valley scandals and things like that. And glass ceiling to access higher position may be more difficult in IT fields. So how to change? Another way to change is really to push on measuring. Why is this so important? Because if you can't measure it, you can't improve it. You need baseline. When you have you have actions, policy actions, you need to see how you progressed. So measuring is very difficult. For example, our UNESCO Institute of Statistics receives a lot of data from the countries, but these data, sometimes they are not completely updated. They are not disaggregated enough. So it's to have series, it's difficult to have series, but we are pushing that way because you need the data for advocacy. what I'm doing now is kind of advocacy. I'm using the data for advocacy. So without data, you can't advocate. You need to really show evidence. And it also interests the media, of course. Of course, we need more studies, more qualitative research from universities, international organizations, UNESCO, and others, think tanks. We need much more research to better understand and provide this evidence-based information to decision makers. We need, of course, and this is really important, proactive policies for gender equality at all levels. From a school level, like École 42, where it was decided, for example, to really increase the number of women enrolled. In the beginning, it was 5%, then it became 26% because it was a decision. So this decision could come at a higher level. And for example, the Cédric Villani report, they have a very high, how to say, objective, which is to have, in 2020, it seems a bit short to me, but 40% of women in artificial intelligence. The report was produced 2 years ago, so I think that policies should be realistic. Otherwise, it can be perceived as a failure, and it's not really what we want. So specific training, we need specific training for teachers and guidance counselors at school. Why specific has been underlined here? It's because it's not any training. We are not going to say to the teachers, look at these pictures, this is advocacy, this is different. You have absolutely to do this and consider that girls can go to, it doesn't work. So it's a specific, very specific training done properly in a specific way. I'm not going to enter into details, but it needs some efforts to do it properly. We need role models. This is important because it works, we know it from research that it works. There are awards, scholarships. I take the example of For Women in Science because we are partners for Women in Science L'Oréal UNESCO program, which works very well actually. But we need more and more, always more and more. Mentoring, coaching programs for teachers, but also in the companies to push women to go higher, in higher positions, for example, in the field they work. Of course, another option is quotas. Quotas is very controversial because some women do not want quotas. So the fact is that we know that it works. It makes a difference. So it's a choice to make or not. It's important, for example, to have quotas in the participation of women in selection and recruitment committees. When you see that, it's like for the Nobel Prize, you don't have enough women there in the jury, you have less people, less women getting the prize. I mean, this is the same thing for every setting. We also need what we call standard or normative instruments, like the recommendations. We worked very hard, and it has been adopted now, the UNESCO recommendation on science and scientific researchers, where we have this recommendation given to all states, to all governments of the world, to have more women in this field, to put into action some policy mechanisms to encourage the participation of women. We are working on it, and we worked on it during the last general conference, which was held the last 2 weeks and finished yesterday. A recommendation on ethics of artificial intelligence, including the gender balance, all the ethical aspects that you also mentioned about facial recognition, the biases of algorithms, and all these issues. Should we be very, very strict or not? Where do we find the right balance in ethics? And of course, another way is to have special events and days like the International Women Girls Day in Science, which is on 11th of February every year. the role of associations and NGOs like yours, the ladies, and Femmes et Numérique also, and many, many others. I'm not going to quote them all, but the GAFAM, I'm putting an M because I think Microsoft is important also. They understood the situation. They understood that the quality of their apps, the quality of their products, of their outcomes, will also depend on women's participation. And this is why all this, you know, women tech makers, Microsoft tech girls, Girls We Code, Nueva La Rosa, it's Pink Cloud in Italy, Apple Entrepreneur Camp, and many others are initiatives that were created or supported by them. What is also crucial to try to change the game and create opportunities is the role of women networks. I mean, it's not necessarily association, and I'm going to take the example of a tiny little structure that we created in Tunisia. It's a network, and we are here 3 members. It's called We4Dev, Women for Development. Emna Gamna here in the front. And we have Marwa Twiri here also. And I will explain to you, we are very happy of this experience because we had, it's not only about technology, and it's really women for development. In Tunisia, it means that we have really a problem of unemployment amongst women who have a degree in higher education. The employment is much higher than for men. So somehow when men go to Europe, you know, the computer science people, we have more opportunities for women, but sometimes they were looking for jobs for years without finding. And what we did a kind of training, including soft skills. So it was about coding, and Marwa benefited from this training. She was one of the 12 students that we organized this with an engineering school who really helped us with the teachers, the professors, the computers, the space. It was a great experience, and Marwa was really doing a good work. And the 12 people that you can see here, all of them found a job. So it's 100% a success. And the life skills part that was provided by one of the members that we can see here, Fatma Mariam Sessi, who has soft skills, a human resources company. And all this was done on a, how to say, benevolent basis. I mean, just to help. And it was really excellent because it created a sense of community, it created a sense of, and now we are going to have the second phase, and I'm happy to say that Marwa found a job here in Paris in a very good company, and she's chief of project in informatics. So it's really great, and we hope to be able to partner with you and to exchange with WiMLDS on how we can move forward. In conclusion, I have to say that to change the numbers, reverse the trend, which is really bad and not going in the right direction, we need to mobilize all energies, those of decision makers, but associations, men, women, public, private sector, because there are too many issues which are at stake not to consider this problem as an important economic and social priority. Thank you very much for your attention.
Okay, we have some time for questions.
Thank you very much. You talked about quotas, which could be a solution. I have a question about it. Do you have a cognitive conflict, and if so, how do you answer it, between being willing to have quota, but not willing to be recruited based on quota?
I don't have the answer, because it's really, as I said, a controversial question. I mean, you can, you need to have a consensus. You need to involve people and say, well, we have this option. What do you think? This is not something we can just give an answer. Personally, I am in favor, but this is my personal vision. But I think that it has to be discussed in depth before being adopted. Yes.
I have an answer to that, but it's my personal answer. But it's just, you're not hired based on quotas. You're hired because you're good.
Thank you very much for your presentation. I would like to recall the picture with many countries and the gap between gender diversity. And don't you think that maybe this positive presence of women in other countries, it is maybe related to a sad fact that women really have tendency to work on less respectful jobs, and maybe in these countries research is some kind of a little bit less respectful, less prestige.
Personally, I don't think so, because the highest you go in your studies, the better you are perceived. So I don't think this is really the case. Maybe in some countries where really researcher is not at all being, how to say, is not well perceived. But I think it's rather countries where the education system, like the former communist countries, they applied really very strict rules for equality between girls and boys. This was something, you know, you find a lot of Russians. I think in Russia, research is very much, how to say, appreciated. It's not something that is neglected, but you have a lot of researchers in this country. Ukraine was mentioned, and other countries from Eastern Europe, because this was the system, and now we have the benefits of it. But also the Arab states and Latin America, same thing. In the Arab states, in Egypt, in Tunisia, with Bourguiba, there was a very equalitarian system where boys and girls had the same, the same rights for education. So when you look at Europe, it was an old system with old stereotypes, with old, you see, and this is something that now is being perpetuated, maybe not in a conscious way, but we noticed this. We noticed that in the former communist country in Central Asia, it's very, we can see it very clearly.